Today we are going to be proving the isosceles trapezoid theorem, which states that the base angles of an isosceles trapezoid are congruent. Now, in order for a trapezoid to be considered isosceles, it must have two parallel sides and two congruent sides. If this is true, theoretically the base angles should be the same, but let's prove that deductively. Here is the isosceles trapezoid ABCD. We know that the sides AB and DC are parallel. We also know that AD is congruent to CB. The definition of an isosceles trapezoid states that this must be true. Therefore, these two facts are considered givens. In order to continue with the proof, let's draw a transversal, CX, from pre-existing point C to new point X. This should be drawn so CX is parallel to AD. We know that it is parallel because we drew it to be that way. We have the ability to do this because of the parallel postulate, which states that through a point you can construct exactly one line parallel to the given line. This brings us to our next statement, which is that ADCX is a parallelogram. We know this because of the opposite sides of a parallelogram are parallel conjecture. It states that if a quadrilateral has two pairs of parallel sides, it must be a parallelogram. Our next statement is that AD is congruent to CX. We know that this must be true because of the opposite sides of a parallelogram are congruent conjecture. If this is the case, that means that CX is also congruent to CB due to the transitive property. The transitive property states that if two objects that are congruent are also congruent to another, they are all congruent to each other. For example, if A equals B and B equals C, then A must also equal C. In this case, if AD is congruent to CB, which we previously proved, and AD is congruent to CX, CX must also be congruent to CB. Our next statement is that angle A is congruent to angle CXB. We know this is true because of the corresponding angles are congruent conjecture. This conjecture states that if two parallel lines are cut by a transversal, the corresponding angles are congruent. We also know that angle CXB is congruent to angle B. This is because of the angles opposite congruent sides are congruent conjecture. Lastly, since this is true, we can deduct that angle A is congruent to angle B. We know this because of the transitive property, which I also explained earlier.